गुड इवनिंग स्टूडेंट्स, वेलकम बैक। आई होप आप लोगों का दशहरा बहुत अच्छा गया होगा। नाउ वी आर वेटिंग फॉर दिवाली। गॉट इट? चलो, टुडे वी आर गोइंग टू स्टार्ट विथ solution of differential equations. Solution of differential equations. Now, you might know what is meant by solution, right? Last time, what we did was we did formation of differential equation. So next part in the differential equation is solution of differential equation. So basically, let me tell you what we'll be going through today. We'll be covering the variable separable differential equations totally. Got it? Variable separable differential equations we are going to do today. So without further, let's start with the session. Chalo. What is solution of a differential equation? So, definition, a relation between the variables without derivatives. That means we do not want the derivatives in the differential equation. We do not want the derivatives in the differential equation. And if we do not want the derivatives in the differential equation, then what can we do is we can integrate, because if we do not want differential equations, that means we have to integrate. So basically, solution of a differential equation means we have to integrate the differential equation. Now, how do we integrate the differential equation? Let's say in general, suppose we have this relation f of x, y, c1, c2, cn, where c1, c2 are, we all know, we have seen this relation, these are arbitrary constants. Got it? And if we integrate the equation, we get this f of x, y, y1, y2, y3, yn, and so on. Obviously, when we'll integrate, then the solution, or when we'll differentiate, the arbitrary constant will be gone. So the reverse process of formation of differential equation is solution of differential equation. That means in formation, we used to differentiate. In solution, we'll integrate. I hope it is clear. So, we saw this last time only we saw the number of arbitrary constant is equals to the order of the differential equation. We'll not go into detail this because we have done it last time. So here, let's look at this. Particular solution. Now there are two types of solution, general solution and particular solution. What is meant by general solution? General solution means the solution in terms of arbitrary constants. And what is particular solution? For particular solution, we'll be given some boundary conditions. I hope you know boundary conditions. If not, we'll see what are boundary conditions in the question. So by using those boundary conditions, we can get the value of arbitrary constant. Once we get the value of arbitrary constant, that becomes a particular solution. Now, let me remind you, in our portion, we only have first order, first degree differential equations. That means if the order is 1, how many arbitrary constants will be there? Only 1. So in our portion or in our syllabus, we only have first order, first degree, as we have seen or we have discussed in the previous lecture. So that means we just have to integrate once and we'll get a general solution. If boundary conditions given, we will find the value of arbitrary constants and then we'll get the particular solution. Got it? Next, this is what I was talking about. We have the differential equation of first order and first degree. Now to solve this, we said we simply need to integrate, but obviously we have divided into different types. So first we are going to discuss is the variable separable type. We are going to discuss the variable separable type. Got it? So variable separable differential equations. What is meant by variable separable? If any doubts still here, then you can say, or you can give me a thumbs up, so we'll proceed the class. Any doubts still here? This was just basically an introduction, but still, you can ask if you have any doubts. Come on, guys. Last time I said, ki please try to make it as communicating or as interactive as possible. Clear till here? Okay. Chalo. So, what is meant by variable separable? Variable separable means here you can see let the given differential equation be dy by dx equals to f of x comma y. Then basically key variable separable ko we can easily, yeah, like as I would like to say is कि dx के साथ सब x वाले टर्म्स को लेके जाओ एंड dy के साथ सब y वाले टर्म्स को. It is as simple as that. All the y terms should be with dy, all the x terms should be with dx. इतना याद रखो, it is all clear if you remember this. All the x terms with dx, y terms with dy. It's the most simple variable separable. And once we got x terms with dx, y terms with dy, we simply integrate. Got it? Chalo. Now let's see the questions. Got it? The concept is very simple. You will see how we do the questions. This, find the general solution. Now, what we have discussed, x wale ko x ke sath, y terms with y. So here, as you can see, I can write the equation as dy over dx is equals to e raised to x into e raised to y by using properties of exponents. So abhi ye dy is equals to, I can write e raised to x into e raised to y dx. Got it? Now only x term should remain with x. That means e raised to x dx will remain this side. I'll take e raised to y on the other side. That means I'll get e raised to minus y dy is equals to e raised to x dx. Once we have completed this, we simply need to integrate both the sides. So if I integrate both the sides, we all know the integration here. What is integration of e raised to minus y? It is minus e raised to minus y is equals. What is integration of e raised to x? It is e raised to x plus c. This is simply my answer. Or if I want to simplify it, I can take e raised to y on that side. So I'll get minus 1 is equals to e raised to x into e raised to y plus c into e raised to y. That means if I rearrange, I'll get e raised to x plus y plus c into e raised to y plus 1 is equals to 0. This is my answer. Got it? So variable separable is very simple. Take y terms with dy, x terms with dx, and solve. And let me tell you, spoiler alert, variable separable is the most basic differential equations. Further, when we do complicated equation, what we do is we'll just simplify those equations into variable separable form. So variable separable is the basis of all differential equation or of all solution of differential equation. Got it? When more complicated equations comes, we'll use some methods, we'll reduce it to variable separable. I hope it is clear. Let's move on to the next question. So the concept is over. Now we just have to practice the question. So I would like y'all, you also try these questions with me or help me to solve this question. Got it? So if you have a book and pen, please grab it fast or go and grab it. We'll solve it simultaneously. Got it? Chalo. Next question. Again, a very simple question. We just have to cross multiply. So if I cross multiply, I'll get dy over 1 plus y square is equals to dx over 1 plus x square. all the y terms are with dy, x terms are with dx. So simply we need to integrate. Simply we need to integrate. And if, one second, yeah, if we integrate, okay. So what is the integration of 1 upon 1 plus y square? It is tan inverse of y is equals to here tan inverse of x plus c. This is my answer. So simple. Got it? All clear till here? If it's clear, you can give a thumbs up. Come on. Or if you have any doubts, you can ask me right away. Do you have any doubt? Or it's clear? Hello, bolo. All good? Yes or no? Okay, super. Chalo. Next question. Here, again, we have to simplify and get all the x terms with dx and y terms with dy. So here, from this, I can take x common. From this, I can take y common. So my equation will look like x into y square plus 1 dx plus y into x square plus 1 dy is equals to 0. Now dx के साथ we only want x. So what we'll do is we'll divide throughout by x square minus 1 into y square plus 1. And same here, we'll divide by x square plus 1 and y square plus 1. So here, y square plus 1 will get cancelled. Here, x square plus 1 will get cancelled. So we'll be left with x dx upon x square plus 1 plus y dy upon y square plus 1 is equals to 0. So simple. Now just all the x terms are with dx, y terms with dy. That means we just need to integrate. Now as you all know, what is the integration? We'll need to multiply with 2. And right hand side, if I multiply with 2, 0 into 2 will be 0. So we all can see that this is the format of, what is this format? F dash of x upon f of x. I hope you got this. This is the format of f dash of f upon f of x. So what is my answer to this? My answer is log of x square plus 1. Log of f of x plus log of y square plus 1 is equals to 0. So if I use the property of log, I'll get ln x square plus 1 into y square plus 1 is equals to c. We forgot the constant of integration, right? We must write is equals to c. So if I remove ln, so I'll get x square plus 1 into y square plus 1 is equal to e raised to c. And I can replace, or I can write e raised to c as y square plus 1 is equals to, suppose, k. Why k? Because e raised to c is another constant, which for simplification I will write it as k. Because in such cases, though we do not have options here, but if suppose they might give options or they might ask in MCQs in JEE, so you will not see this answer. You will not see this answer in the options. The answer that you will see will be this one, the box one. You will not see this answer. The answer you will see is the box one. Why? Because the answer will be presented in the most simplest form. And rarely you will see log in the answer or log in the option. Got it? So let's move on to the next question. This one. Again, now I want you all to try this. It is a very simple question. So I'll give you 1 minute to try it. Obviously, you should know the basic integrations. So let's give you some time to try it, and then I do. Chalo. Acha, 1 minute is very zyada kya? So I'll give you 30 seconds. Got it? Chalo. 30 seconds. If you can do it yourself, then it's very good. Any progress? Got it? Chalo, let's see what you have done. So you just have to separate x with y and x with dx and y with dy. So basically you just have to cross multiply. So we'll get dy over y square plus 2y is equals to dx over x minus 1, and then we integrate both the sides. So right hand side, so integration is simple. On left hand side, what we'll have to do is denominator में will get y into y plus 2. So you can replicate the denominator by writing y plus 2 minus y. So if I write y plus 2 minus y, what is left is 2. 2 is left here, right? So that means I'll divide by 2 on the outside. So 2 is adjusted here. Y minus y to 0. So y is also adjusted. So left hand side is adjusted. Right hand side mein it is still integration of dx upon x minus 1. Now on the left hand side, what I can do? I can split the denominator with numerator. So I'll get 1 upon y minus 1 upon y plus 2 dy is equals to integration of dx upon x minus 1. So all the integrals are easy. So I'll get half. What is integration of 1 upon y? ln y minus ln y plus 2 is equals to here ln x minus 1 plus c. So if you can see, same, there are many logs, and I told you you will hardly find any options with logs, so we have to simplify. How can we simplify? 2 को cross multiply, so I'll get ln here y upon y plus 2 is equals to 2 ln x minus 1 plus, we can write it as ln k. We can write 2c को ln k लिख सकते हैं. So on the left hand side, I am still getting y upon y plus 2 is equals to, ये ln ऊपर आ जाएगा तो ln x minus 1 the whole square into k by using property of log. Now again cancel out log on both the side. So finally my y will be equal to y plus 2 into x minus 1 the whole square into k. This is my answer. You will find this answer in the option. Got it? So basically we are very familiar with this. So let's do more simplification or more tough questions. This one. I have to remember this also. Same we have to do. We just have to cross multiply. So again, I will give you 30 seconds. Come on. 30 seconds दिया आपको. चलो. Till then, I'll drink some water. Chalo, I'm back. So, if you could do anything, same. What must you have done is same cross multiply. So, if I'll cross multiply, I'll get dy over y square plus y plus 1 plus dx by x square plus x plus 1 equals to 0. So now we just have to integrate both the sides. So in denominator, what we have? These both are quadratic. So how do we integrate these type? We just simply use perfect square or we complete the square. So what can I do is here in denominator, I can do it as I'll add 1 by 4 and I'll subtract 1 by 4. Got it? I am not doing it here because the only difference is x का. So last में will adjust x, y की जगह पे x रख देंगे. Got it? So plus this, I will take it as it is. So here I'll get integration of dy upon, this is y plus half the whole square and plus root 3 by 2 the whole square. I hope you got it. And here, same I'll get integration dx over x plus half the whole square plus root 3 by 2 the whole square equals to 0. So, what is the integration of this? It is 1 by 8 tan inverse of x by 8. So, that means this is a, right? So 1 by a का ऊपर reciprocal 2 by root 3 into tan inverse of y plus half upon root 3 by 2 plus same 2 by root 3 tan inverse of x plus half upon root 3 by 2 is equals to c. So I can take 2 by root 3 common. So if I take 2 by root 3 common, अंदर बचेगा tan inverse of after taking LCM. So 2y plus 1 upon root 3 plus tan inverse of 2x plus 1 upon root 3. So I can cross multiply root 3 by 2 here and that will become a new arbitrary constant which I can write it as root 3 plus tan inverse of 2x plus 1 upon root 3 is equals to k. This is my answer. I hope you got it. Your answer will be in this format. Your answer will be in this format. So let's move on to the next question. If you have any doubts here, you can raise your hand. And if not, give me a thumbs up so we can move on to the next questions. Chalo, fatafat. You are not interacting today. Please start interacting. Or else bus, I'll talk and talk and talk and you'll get bored. I also get bored. Got it? Chalo. Come on guys. यहाँ तक clear है तो give me a thumbs up. Yes, no, you can also unmute yourself and talk. Clear till here? Hello? Clear till here? Okay. One of them gave a thumbs up. Others? What about others? All good? Clear till here? Come on, guys. You can at least give a thumbs up. सब बोरिंग मत बनाना मेरे लिए. All good? Okay. Chalo. Let's move on to the next. Next question is already on your screen. So, same. What can we do here is y को y के साथ लिख लो, x को x के साथ. So just basically we'll have to divide throughout by y. If I divide throughout by y, no, na, I'll have to cross multiply basically. So I think I'll get y dy upon y plus 1 plus dx over e raised to x plus 1 equals to 0. I hope I didn't make a mistake, right? Y dy, yeah, I'll get this, right? After dividing or after cross multiplying and simplifying. So now just it is left to integrate both the sides. So if I integrate both the sides, what is this? Here I can do y plus 1 minus 1 upon y plus 1, add subtract y, and here dx over e raised to x plus 1. So you know how to do these types of integration. Here we take e raised to x common from denominator, if you remember. So I'll take e raised to x common. So I'll be left with 1 plus e raised to minus x dx equals to 0. Here I can split the denominator. I'll get 1 minus 1 upon y plus 1 dy plus. Here e raised to x को इसको ऊपर लेके जाओ. So it will be e raised to minus x dx upon 1 plus e raised to minus x equals to 0. Now you can see this is a form of f dash of x upon f of x. So you got it? We just have to adjust the minus sign here. So we'll adjust after integrating. So after integrating, I get this equation of 1 is y minus ln 1 plus y minus, you have adjust the minus sign here because e raised to minus x, the derivative is minus e raised to minus x. So here I get same ln 1 plus e raised to minus x equals to c. Again, I told you we can simplify the ln. So I can take minus common and I can write ln of 1 plus y into 1 plus e raised to minus x equals to c. So ln को हटा देता है. So what I'll get? If I move this on the right hand side, I'll get ln 1 plus y into 1 plus e raised to minus x equals to y minus c. So 1 plus y into 1 plus e raised to minus x will be equal to e raised to y minus c. So I can write as into e raised to minus c. Now I can write this as another constant k. So my final answer will be 1 plus y into 1 plus e raised to minus x equals to k times e raised to the power y. This is my answer. So I hope you are getting used to simplification. Many times we'll be getting log in the answer, but we'll not leave there, we'll simplify. You'll get what I'm trying to say when you see the MCQ, when we have the option in the coming questions. So then you'll see why we have to simplify if we have log. Got it? Let's move on to the next question. Clear, this question is clear. If it is clear, give me a thumbs up so we can move on to the next question. Okay, very good. Chalo. So this one. This is a type of word problem you can see, but it is very simple, very, very simple. So we have to find equation of the curve passing through 1, 1 and having gradient. What do you mean by gradient? Gradient means slope. And we all know the slope is given by dy by dx is equals to 2y upon x. So simple. Just cross multiply. So I'll get 1 upon 2 integration dy over y is equals to integration dx over x. So basically I'll get 1 by 2 ln y is equals to ln x plus c. Now I'm trying to say this. In option, all the four options, you will not see ln log. So what does that mean? That means we have to simplify the log and get rid of the log. So first, let us get a value of c. It passes to 1 comma 1. So 1 comma 1 must satisfy. So if I put 1 comma 1, I'll get 1 by 2 ln 1 is equals to ln 1 plus c. What is ln 1? 0, 0. That means c is 0. So my answer is 1 by 2 ln y is equals to ln x. Now, I want you all to simplify this and get me which option it is, A, B, C, or D. Chalo. I'll give you 30 seconds. 30 seconds is also very, very much. We'll be doing 10 to 15 seconds. Chalo, fast. Okay, you already got day one. Very good. Day one is saying option is 4. Okay. Y equals to x square. Super. So we'll just cross multiply. So I'll get ln y is equals to 2 ln x. By Log property, I can write ln y is equals to ln x square. If we take anti-log on both the sides, so I'll get y is equals to x square. This is my answer. Got it? Y is equals to x square. Now, many a times they might give option in some other way. What is this other way? They can write as option 1, they can write a rectangular hyperbola. Instead of equation, they can give you to find the nature of equation. Nature means which type of curve it is. It's a circle, it's not a circle, but we can say it is a circle. So if we don't know to simplify this equation, we will never be able to find the nature of the curve. Got it? So these are more smarter options, the rectangular hyperbola, straight line, and that. Because we must know ki, we got y equal to x square. So what y equal to x square represents? Is it a rectangular hyperbola? It is a circle? Is it a straight line? Or is it a sophisticated way to ask the options? Got it? Let's move on to the next question. This one. Again, I was saying when you get options, you'll see why we simplify law. This is obviously we are variable separable. That means it will be the question on variable separable. Got it? Chalo. Here we can use the exponential law, right? I can write the equation as dy over dx is equal to, I can take e raised to minus y common. So I'll be left with e raised to x plus e raised to 2 ln x. And if I cross multiply, I'll get e raised to y dy is equal to e raised to x plus, here I can simplify e raised to ln x square dx. Now, important, what is this equal to? Can anyone tell me what is this equal to by using property of log? It is very simple. What can I write this? The blue highlighted part. Come on, guys. What can I write it this? E raised to log of x square. You know this property of log, right? I hope you know it. X square. Superb. Superb. Very good. That means my equation is reduced to e raised to y dy is equals to e raised to x plus x square. 1 second. Yeah. Plus x square dx. Now, what is left to do? We just have to integrate on both the sides. All the integrations we know, so we can easily integrate. So this will be e raised to y is equals to e raised to x plus x square ka x cube by 3 plus c. So simple. You can directly match, or directly the option is given, which is option 2. Got it? Chalo, let's move on to the next part. Now, next is equations reducible to variable separable. So I have divided into some cases which will be better to identify and better to solve. So first case is the differential equation is this type, this format. Linear upon linear, where there is a relation between some coefficients. This is the relation. A1 plus B is equal to 0. Then this equation can be solved by proper grouping of the terms. We will also see this question similar to case 1 in the last part of the chapter, which we call exact differential. We'll discuss what is called exact differential, but we'll introduce the word exact differential in this case. Second is case 2. Case 2 is very simple. You will see same linear upon linear, but part of the linear will be same in numerator as well as in denominator. So how can we solve it? This linear will be same in numerator and denominator. So simply substitute ax plus by ko we substitute. Either v or t, anything you can substitute. Got it? And case 3 is, consider this. Dy by dx is a function of some linear. It is a function of some linear. So what to do? Same. Substitute linear as t. So case 2 and case 3 are not very different. It is just in case 2 we have a fraction, and there is a linear part same in numerator and denominator. And here we only have a linear. So it will be more clear for the questions. Let's look at the questions here. So this I can write it as, first always make it a habit to write the equation as dy by dx is equals to something. So dy by dx will be equals to x plus y plus 1 upon x plus y minus 1. So I think you understood which case it is. It is case number 2, where we can see some common part in numerator and denominator. Here, case 2, some common part in numerator and denominator. What was the method? Substitute that common part. So here, we'll substitute x plus y equals to t. So if I differentiate with respect to x, I'll get 1 plus dy over dx is equals to dt by dx. Obviously ये तो इंटीग्रेशन के जमाने से चलते आ रहा है ना, Whenever we substitute, we always need to differentiate. So, this equation will become t plus 1 upon t minus 1. Now substitute the value of dy by dx here. So I'll get 1 plus t plus 1 upon t minus 1 is equals to dt by dx. Once we do this, now it is very simple. In the start, I told you that variable separable is the base. That means whatever methods we do, lastly, in the last step, we have to do variable separable. That means t के टर्म्स को dt के साथ लिखो, x के टर्म्स को dx के साथ. यहाँ पे भी substituted y ना, so there is no y, there is t and x. First there was y and x, but after substitution it became t and x. So every question may last will only do this. We'll do variable separable. First let's simplify LHS. If I take LCM, I'll get 2t upon t minus 1. I skipped one step. I hope you got it. Now just need to cross multiply. So left hand side I'll get dx is equals to t minus 1 upon 2t dt. Just integrate. So integrating left hand side mein I can split, sorry, right hand side I can split the denominator. So what I'll get is 1 by 2 ko bahar le liya, 1 minus 1 by t dt. So integration of dx is x is equals to half t minus ln t plus c. I can cross multiply 2 and I'll substitute the value of t. So I'll get 2x is equals to t was x plus y minus ln x plus y plus c. So one of the x will get cancelled. I get y is equal to x plus ln x plus y plus c. This is my answer. I hope you got it. Correct? So variable separable, 3 cases we have divided. Each of the case is very simple. In each of the case, we need to substitute. I told you case 1 will go in more detail in the last part, which is exact differential. Sorry. Got it? So we'll just introduce case 1 here. The next question. Next question is also the same because you just have to take 2 common from the denominator and you will see. So you can see there is some same part to y. What does the method say? The method says that put x minus 2y for t, differentiate with respect to x. So 1 minus 2 dy by dx is equals to dt by dx. So this dy by dx will now become t plus 1 upon 2t. So substitute the value of dy by dx here. So I'll get 1 minus 2 and 2 will get cancelled. T plus 1 upon t is equal to d. If I take LCM, I think I left with minus 1 by t, right? Yeah, is equals to dt by dx. Very simple. Just cross multiply. So minus dx equals to t dt. Integrate both the sides. So very simple integration I got. Minus x is equals to t square by 2 plus c. Cross multiply 2 and 3 substitute the value of t. So minus 2x is equals to what is t? X minus 2y. X minus 2y the whole square plus c. This is my answer. You can open this whole square, but it will make no difference. Got it? So I hope it is clear. Same part in numerator denominator, substitute that t. Let's move on to the next question. This question. Given is this. So I told you you always make a habit of writing the differential equation as dy by dx is equals to some function. Dy by dx on one side, mostly on left hand side, is equals to some function. So here I need to get rid of sine inverse. Sine inverse ko udhar bhejo. So I'll get dy by dx is equals to sine x plus y. This is the third case. Do you remember the third case? Third case was dy by dx is equals to function of some linear term. So put linear ko t. So here also dy by dx is a function of linear. What is a linear term? It is x plus y. Simple. X plus y ko t. So differentiating with respect to x, I'll get 1 plus dy over dx is equals to dt over dx. And what dy over dx will become? It will become sine t. So simply substitute this here. So my equation will be 1 plus sine t is equals to dt by dx. Cross multiply, so I'll get dx is equals to dt upon 1 plus sine t. Do you know how to solve RHS? RHS may we simply rationalize. So integration of dx will be equal to integration of 1 minus sine t upon cos square t dt. If I rationalize, I'll get this. And if I split the numerator, I'll get integration of sec square t minus sec t into tan t dt. All the functions are integrable. So my final answer will be x is equals to sec square t ka integration tan t minus sec of t plus c. Just resubstitute. So I'll get x equals to tan of x plus y minus sec x plus y plus c. This is my answer. I hope it is clear. Is it clear till now, or you have any doubts? It is clear. You can give. Acha, very good. You already gave thumbs up. You know my dialogue or what? Super. Chalo. Let's move on to the next question. This question is also same. You can see dy by dx is a function of linear. So just put this linear as t. Now we know from integration कि under root के नीचे term है ना. So instead of t, I'll put y minus x as t square. Adat, you can say it is a habit ना. कि whenever we have integration में भी ऐसे ही करते थे हम लोग. So if I differentiate with respect to y, I'll get dy over dx minus differentiate with respect to x is equals to 2t dt by dx. What dy by dx has become? Dy by dx has become t. Substitute this here. I'll get t minus 1 is equals to 2t dt over dx. Now we just need to cross multiply. So I'll get dx is equals to 2t upon t minus 1 dt. Integrate both the sides. Do you know how to integrate this? Same, plus 1 minus 1 will do. So integration of dx is equals to, I'll take 2 bar t minus 1 plus 1 upon t minus 1. So I'll get integration dx is equals to 2 integration of 1 plus 1 upon t minus 1 dt. Simply integrate x equals to 2 into t plus ln t minus 1 plus c. Resubstitute. What was t? T was under root of y minus x. So I'll get x equals to 2 times under root of y minus x plus ln under root of y minus x minus 1 plus c. The answer looks horrible, but what can we do? It is the answer. Got it? We cannot simplify any further. So this will be the same answer you will get in the options. Now, only one of the things is remaining, which is this. That is, that I was talking about exact differential, case 1. See, here the main thing to note is this. Same, it is linear upon linear. So linear upon linear, my case 1 is, you see these terms. In numerator, see coefficient of y, and in denominator, see coefficient of x. And add those. If we add 5 and minus y, we get 0. What do we get? 0. This means this is very this is case 1. I already told you, I'm repeating again because it's important. We will see this in more detail as exact differentiable. We are just introducing it here. So how to identify case 1? Y का coefficient numerator, x का coefficient denominator. Add those. If we get 0, that means it can be solved by proper grouping of the terms. What is meant by proper grouping? Proper grouping means you have to make exact how y solving. We cross multiply. So I get 5x dy plus 2y dy minus 4 dy is equals to minus 12x dx minus 5y dx plus 9 dx. Now they are not proper or not integrated. The rest of these terms are integrable. Why? Because this is x dy. We cannot integrate x with respect to y. Same is y integrate x dx can easily integrate. So I get x y dx. I am taking everything on the left hand side. Right? All the y dy minus 4 dy plus 12x dx minus 9 dx. This is a derivative of x into y. It is x. So u derivative of v plus v derivative of u. Now this is what we call exact differentiable. That means this is an exact differentiable of xy. Because if I differentiate xy, I'll get this term x dy plus y dx. Now what is remaining? Just simply to integrate. All of these integrations we know. So I get integration and derivative will get cancelled. I'll get 5xy plus y square minus 4y plus 6x square minus 9x equals to 0. This is my answer. I hope you got it. Got it? This is called exact differentiable. Why? Because x dy plus y dx is the exact differentiable of dxy. We have separate topic in the last, but I thought I'll just introduce you here because it is simply variable separable only. Got it? Clear till here? Give me a thumbs up. And time is up. So we'll continue in the next lecture, which is tomorrow. Till then, bye bye everyone. Take care.